Good afternoon, students. We are moving on to uh, another high performance fiber, glass fibers. In the previous two lectures, we have been discussing about high performance fibers such as carbon fibers and aramid fibers. I hope you may have learned it well. So we are moving on to another important and mostly used high performance fiber, which is the glass fibers. So what is a glass fiber? It is an important category of the high performance manufactured high performance fibers. There are many useful properties in glass fiber like incombustibility, corrosion resistance, high strength, moderate density, good thermal and sound insulation, and electrical properties also. And these fibers are actually a very inexpensive fiber when you compare it with other high performance fibers like aramid or carbon or any other high performance fiber. This is a very common fiber where there is a practically inexhaustible supply of raw material for their production, because the raw material itself is obtained from the sand. Okay, it's a mineral fiber. Basically, it's a inorganic. It's a mineral fiber. So how do this ASTM define this glass fiber? If you see that ASTM, which is the American Society for Testing Materials, it states that a glass is an inorganic product of fusion which has cooled to a rigid condition without crystallizing. So this statement is very important. It is an inorganic product of fusion which has cooled to a rigid condition without crystallizing. Means some molten material is there where you take some minerals first and then you heat it to a very high temperature, and then when it reaches its melting temperature you cool them, and then it becomes rigid without getting crystallized. That is very important. Normally क्या होता है, for any fiber formation crystallizing is very important, but whereas in glass it is not a crystalline fiber. Okay, it is a amorphous solid. Okay, so it is neither crystalline nor all its molecules are in the oriented state. It's an isotropic 3D network, means same properties in all the direction. Okay, so if you see in the axial direction or in the longitudinal direction or the transverse direction, the properties remain the same. This is actually completely contrast to the carbon fibers, which is totally direction dependent. Okay, so it's a amorphous solid. Okay, so it doesn't crystallize. So how this glass fiber is manufactured? Before going into that, we must know the glass chemistry. So what is this raw material for the glass? As I have told you, the raw material is a mineral. Okay, so the raw material for the glass fiber is silica. Okay, SiO2, which is the silicon dioxide, or you can short form you can call them as silica. So this silica you need to melt to a very high temperature, because the melting temperature of the silica is very high, around say 1713 degrees centigrade. Okay, so normally if you see, using that kind of a temperature may definitely form the glass, but you will not get the required chemical properties, and also difficulty in processing when you use that kind of a high temperatures. Okay, so because of that, we need to reduce this temperature. How to reduce the temperature? We have to add some fillers. Okay, some impurities we have to add. Okay, so another point which you need to understand is this mineral which you are using as a raw material, that silica, which when you heat it to a very high temperature and rapidly cool them, what will happen? This molten material will get thickened, and you will stir. The molecules will not be in a proper arrangement. It will not get arranged. So because of this also, what we do is we incorporate some impurities in the glass fiber manufacture. This is to be understood first. You need to add some impurity. Okay, you can add. There are a number of impurities are there. One of the impurity which is shown here is the soda, which is the sodium oxide. You can add 25% soda, so that what will happen? That will reduce the liquidus temperature, that is the melting temperature. Okay, it will reduce the melting temperature from 1713 to 793 degrees centigrade, so that the viscosity also will drop down substantially, so that you can extrude the glass filament. Okay, this is the rough overview of how this glass chemistry works. We will see the impurities and the other how it is manufactured in detail in the coming slides. So if you just observe the glass fiber, what is there in the structure? If you see, there are mainly three important components. One is the silicon atom, which cause that is the basic raw material that will be there. You can see here, and O, and this circle which is shown here is the O type of circle, which is the oxygen atom. And sodium ion, it has come from the, if you just recall the previous slide, sodium oxide, you have added it as a impurity, okay, to bring down the temperature, so that the sodium ion, you know very well that it contains positive charge, so that will also will form some ions. So you can see this is a type of a 3D network. Okay, so in order to control that viscosity, we add this kind of a impurity, or you can say modifiers. You can call them as a different names, like a modifier or as a fluxing ions. You can call them in a number of ways, so that you can make a 2D structure, which is a glass fiber. So normally, if you see this impurities which you are adding, it can be called in a different names, like a as I've told you, it is an intermediate or a modifier or an impurity, whatever name you can call. So, but you can see there are different oxides can be used for making the glass. It is not hard and fast that only with silicon dioxide. There are other oxides also, like B2O3. You can use GeO2, which is the germanium oxide, or phosphorus pentoxide, or vanadium pentoxide, or even arsenic trioxide. There are a number of oxide, even see beryllium trioxide, this B2O3. Many kind of oxides are inorganic oxides are there, where you can metal oxides, you can use it as a raw material, which is called the glass former. Okay, so this can be used many in, so but silica is very commonly available, so we are using it. Okay, so apart from that, you can, there are some other intermediates are also there. Normally this glass form composition, it is classified into, it's written glass form or intermediate or modifier. You can number of oxides are there, like aluminum trioxide, Sb2O3, PbO, which is the lead oxide or zinc oxide. Okay, and antimony trioxide, and even you see there are some other oxides also will be there. So the opportunities are many metal oxides can be used as a raw material, but since silica is very commonly available, we are using it. And for bringing down the temperature, I told you, as I told you, you have to add some intermediate or a impurity or a modifier. You have to, there are a number of oxides are there, like a sodium oxide, which we have discussed in the previously, which if you just remember. Apart from that, you can add a calcium oxide or a potassium oxide or a barium oxide or a lithium oxide also you can add. Okay, so normally if you see all these metal oxides which we are adding, these are the alkaline earth metals. If you just recall your school's periodic table, there are alkaline earth metals you may have read. Okay, so here alkaline earth metal oxide, these are added, so that it will produce a glass fiber. There are some advantages and disadvantages of using different for glass formers. For example, if you take sodium oxide and silica sand, and then you mix them in some particular ratio, so that that glass may not have that kind of a property. You can use if you use calcium oxide, just we discussed previously, the modifiers, we use a calcium oxide, then calcium oxide is actually a better one, because you see calcium oxide, it will not dissolve like water, because it improves the chemical stability. And there is another glass called the soda lime glass, which we will be discussing. So there are different ways, actually different type of modifiers you can use, ingredients you can add to, if you want a particular property, because sometimes you want a high electrical resistance, sometimes you want a high, it should be glass should be strong, sometimes you want a high chemical resistance, sometimes you want multiple properties. So depending upon that, you can modify the fluxing agent or the modifiers. You can change it so that you will get the required property. Okay, so now we will move on to discussing about manufacture. Already I have given you an overview of how it should be manufactured. So if you just observe this glass manufacture, I have told you the raw material we are going to use an inorganic metal oxide, which is the silicon dioxide. So the raw material what you are taking, which is called the glass former, you will use a furnace where a very high temperature is there, and you will use this. You take the weight, how much you want to melt, that you will take, and then once it becomes melted at a very high temperature, you just use some type of an extrusion to extrude it so that glass will be formed into marbles or rods, so that it can be heat set or annealed or whatever, and it can be cooled down to required temperature. If you just see this diagram, this is how the manufacturing works. First thing is the weighing and mixing. You need to have that glass former, whichever is the raw material. You transport them through the conveyor belts of how much quantity you want, and then you just transport it to the furnace where there will be a melting take place, and then that will move on to further through the bushings where it will be just like an extruder. If you just recall the melt spinning process, there it will get extruded into some particular cross section where the filament formation take place. Okay, and then after that you will use some size application, okay, like a spin finish in polyester or any kind of a man-made fiber manufacture, and then you will just wind it. Okay, this we will see separately. The sizing application is one of the very important in the glass fiber manufacture, that we will see later how what is the chemistry behind it. So if you just see what we do is it can be, if you want to process it only batch wise, you can do it, or if you want to do it in a continuous method, that is also possible. The diagram which is shown here is it's actually a continuous type of a method where the molten glass, it is spread into a series of electrically heated bushings, which has a number of several hundred holes in its base. You can see here, this is several hundred holes are there. The glass will flow under the hydrostatic pressure, and fine filaments of say around 18 to 15 micron, they are drawn mechanically downwards at a high speed, say 1000 meters per minute. You can vary the process parameters like a viscosity. You can change by controlling the addition of the impurity, and the pressure, hydrostatic pressure, diameter and length of the nozzle, depending upon how much length you can keep or how much diameter of the fiber you need, that you can modify so that you will get a different you can have the control to decide what you want. Okay, process optimization is possible, and after that the fibers are cooled, then coated with the size, which is one of the important application in the glass manufacture. Then you assemble it into a strand and then wound it to produce a cake, or you can just traverse it and then wind it so that it can be sent for further processing. Okay, so here one of the important application in the glass fiber, one of the most important application in the glass fiber is the size application. Okay, it's like a spin finish. If you just recall, in the melt spinning we have discussed the spin finish as a separate process. So here you see the spin finish, it will contain a number of chemicals. For example, why it is done, why we are doing this. If you do not use the size, what will happen? You will not get the proper handle. The word handleability is very important. You will not get the handle. In order to get a smooth feeling, when you touch a glass, you feel a smoothness. Okay, how do you get that smoothness? It is because of the sizing application. Okay, so for that you need to add this size or the finish. So you add a number of finishing agents. Normally, if you say a word called size, it will contain some 5-6 ingredients, like an adhesion promoter or a coupling agent. a protective polymer size or a film former, a lubricant like an oil, and a surfactant, an anti-static agent to prevent the static charge accumulation, then optional polymeric binder, so that there are multiple ingredients will be there in the size. Okay, so if you see glass fibers, I'm sorry, if you see this coupling agents or the which is used in the size used in the sizing application, there are a number of coupling agents are there. All these, if you observe, these are the resins basically. Okay, so there are multiple coupling agents for promoting this adhesion. They are called the vinyl, epoxy, methacrylate. Many thermosetting polymers are there. You see epoxy and vinyl, these are the thermoset polymers. Then acrylic polymers are like methacrylate, cationic methacrylate, amine, cycloaliphatic epoxide, titanate. There are many coupling agents can be used so that the glass and the resin adhesion will be promoted. So that what will happen if the glass and the resin gets proper adhesion, so that the stress can be transferred very efficiently. Okay, just you can see the different coupling agents here. You can see the structures, vinyl, epoxy. These are just if you're uncomfortable with the formulas, just know these names. You should know these names, that there are different coupling agents to promote the glass and resin adhesion. Okay, so if you just see, this is the you can see here, this is the glass fiber structure. You can or SiO, which is surrounded by 2 oxygen, 3 oxygen, and R is there. You can see here this glass. If you just when it undergoes some dehydration or hydration, if you add some water or anything, finally this glass fiber structure, over this fiber structure, this coupling agents will form an attachment. Okay, see, for example, if you normally this it is like a composite where the glass and the resin it will get attached. If you see in the aqueous solution, the presence of an acetic acid, where normally under the acidic pH we do this glass and the resin undergoes this fixation. So this alkoxy RO groups, you can see here, this RO is an alkoxy group where it will hydrolyze and polymerize to give a linear and branched polyhydroxyloxanes. Okay, so just this over these glass structures, this this RO groups, it will get hydrolyzed. You can see here this RO got hydrolyzed, so that it will get this Si groups will get attached to the structure. Okay, so you can see here, this is the type of a deposit where the over the structure, this Si groups will be anchoring because it has got attached. Some adhesion has facilitated. Okay, so finally it will lead to a structure where it is a linear and branched polyhydroxyloxane. Okay, like this. Okay, so this is how the coupling agent actually works. If you see, in the different forms of glass fibers are available. Normally, glass is actually a very versatile type of a fiber where it is sold in different forms. You can use it in the form of a strands, or you can use it in the form of a roving, where it is a collection of parallel strands. This can be wound in the form of a cylindrical package and can be used in filament winding and pultrusion process, because this filament winding and pultrusion, it is a composite manufacturing process. Normally, if you see, this glass fiber is not used in apparel. It is 100% used in the technical textiles. Okay, so this composite manufacturing, there are various techniques are there which you may learn if you study the fibers for composite subject, where there are multiple techniques are there called the filament winding and pultrusion process, where this rovings are used. Okay, and another is the chopped strands, where the parallel strands, these are cut into some small pieces. Just I will show you one pics, if you just remember when we started our lecture, something like this. Okay, these are the chopped strands where it is cut into different pieces. So what will happen? The length of that strand will get reduced, say, to 3 to 12 millimeter in different form. You can use it in a form of strand or a roving or a chopped strand, because in composite manufacturing, the raw material, the fiber, can be used in different forms. You can use it in a form of a continuous strand or a roving or a chopped strand or a milled fiber. Milled fiber is something where you crushed the glass fiber into different pieces. Okay, you're taking the glass fiber and then just breaking it into small pieces where the size will get reduced to 0.8 to 3.2 millimeter by using any kind of a milling, like a hammer milling or a ball milling you can use, so that you can crush them. So that all these are used in the composites. Okay, these are the various forms of glass fibers in which it is sold. Okay, so that you need to understand. So next is the properties of glass fiber. As I've already told you, it is a glass fiber is a amorphous solid. Okay, it is an amorphous material having a micro heterogeneous structure with a 3D atomic bonding without any long range order or the orientation. Okay, but in the atomic level there is a 3D atomic bonding, but the structure you see, it is a normal 2D structure. So if you can, once if you make a composite there, you can actually make this 3D type of a structure you can make. So these glass fibers, they have a unique structure, unique characteristic, that is they are isotropic, means same property in all the direction, where in the longitudinal or in the transverse direction it is the same. Okay, but the modulus and the strength of the glass fibers, it is actually lower when comparing with the other high performance fibers. Like if you compare it with the aramid or carbon fiber, this modulus and strength may be lower, but elongation to break is very high, because this fiber, if you see the stress strain curve, it will actually, before making, it will undergo some plastic deformation. It will take more stress to break, so that the elongation, it will elongate to some extent before it undergoes breaking. And advantage is that it has a high temperature resistance. Okay, because the melting point of the silica itself is around 1713, and you have brought them to 700 degrees centigrade. So this fiber has a high temperature resistance and low thermal expansion. If you just compare it with the metals normally have a high temperature thermal expansion. If you just apply some temperature, it will expand. So the coefficient of thermal expansion will be higher in the metal, but whereas for the glass fiber, if you apply temperature, it will not expand that much. It has a low thermal expansion. Okay, but but there are some disadvantages also in glass. Important disadvantages: it's a brittle kind of a material. It will break. It will lead to fracture. Okay. The advantage, great advantage of the glass fiber is it is an inexpensive high performance fiber. That is why it is most commonly used. If you see any kind of a composite, you can easily hear these words called GFRP, which is the glass fiber reinforced polymer, because this mostly used fiber reinforcing material in the composites. Okay, so now we'll go on to some physical properties of glass. There are different types of glass which you will see them. There are some 4 to 5 different types called the C glass, E glass, AR glass, S glass. What is the C, E, AR, and S that we will see now? C glass means it's a chemical resistant glass. Okay. So if you just see, the chemical resistance of this glass will be higher. And E glass is the electrical resistance. Okay, electrical insulation glass, electrical resistant glass. And AR is the very common glass, which is the alkali resistant glass. And S glass is the strong glass. Okay, that is why if you just see from the word strong, it means that it will have a A high tensile strength, if you just see these values which are written here, you can see the strength is also very high and the modulus is also very high if you compare it with the other uh, glass fibers. Okay, and these fibers, despite having strength, it also has a high elongation to break. This elongation percentage is also higher. Okay, so you see, this is how you can understand different types of glass, how it is different in their different properties. And if you see the composition in the molecular level, what is that composition of these glass? Okay. First, we will see the very most common glass, which is called the AR glass. AR means alkali resistance. Okay, this glass, if you see the silicon dioxide percentage, which is the basic raw material, that has around 62 to 62 percentage, 62.2 percentage. And if you observe other oxide which you have added, you can see the aluminum trioxide is 0.74, calcium oxide is 5.2, magnesium oxide is 0.16, 14.3 percentage of sodium oxide, and other zirconium oxide of 16.0, like that. There are multiple other oxides also present in that. But this is a soda lime silicate glass, or you can call them, it is an alkali resistant glass. It's a soda like you can call them in a soda lime silicate glass also. And C glass, it is a chemical resistant glass. It can also be called calcium borosilicate glass. Okay. So this is a chemically stable in the corrosive acids. Wherever the application requires good chemical resistance, there you can use this. You can find here the silicon dioxide percentage is higher in this. Okay, and you can see the calcium, it is higher in this application. And if you see other glass, which is called the E glass, which is the electrical resistant glass. Okay, this also is otherwise called the alumina calcium borosilicate glass. Okay, so if you see this words calcium borosilicate or soda lime, it means that you can observe from here itself these metal oxide percentage will also be higher, use will be higher. You can see here in the E glass, apart from the silicon dioxide, this alumina trioxide is higher, calcium borosilicate is higher, and here this B3O3, which is the borosilicate, this is also used is higher. This borosilicate is used in both the C glass as well as in the E glass. And another glass is the S glass, which is called the magnesium aluminosilicate glass. Okay, so here you see this magnesium aluminosilicate. Apart from the silicon dioxide, you have the aluminium and the magnesium. Rest are all absent. So this is for the high strength modulus and stability to under high temperature. Wherever, if you want to fix a window where the window glass should not be easily broken, where a high strength is required, in that case you can use this S glass. So there are different glasses are there with the different compositions. So if you come down to applications of glass. So if you see this AR glass is a very common glass. It is used in bottles and glazing where some shining is required. Those applications use this soda lime glass or alkali resistant glass. Okay. The common glasses like E glass, C glass, S glass, or electrical glass, these have a good strength and also good weathering properties and electrical properties also. And chemical corrosion, if you C glass, if you want to use wherever the end use requires chemical resistance, there you can use the C glass. E glass, if you see, it is a more expensive glass because it gives electrical resistance. So it's one of the important application. It is more expensive and has a lower strength when you compare it with the S glass. So S glass is the more expensive glass. Okay. So this already we have seen wherever application requires a high strength, like in aircrafts industry, where if you're traveling in an aeroplane where there is a window will be there, where there is a high strength is required, which cannot be easily broken. Though that kind of glasses can be, they are made up of S glasses. Okay, wherever this application requires a high strength and high modulus and high elongation to break, this S glass is useful. And apart from that, this glass fibers, they have a plenty of applications. You can see this is mainly used as a reinforcement. Okay, like carbon fibers, this glass fiber we do not use it alone normally. In the textile application, if you see for the composites, this is used as a reinforcement. Okay, which reinforcement is a one which adds the strength to a material. Okay, see, for example, you can take the glass fiber and take a thermoplastic polymer or a thermoset polymer and mix them and make a composite, so that it can be used in a different high-end application, like a technical application in the form of in the motor cars, rubber tires, and underground petrol storage tanks from plastics, and reinforcement of plastics. Wherever the plastics require good strength, there you can use this. And even in the cement, you can mix it with the cement, so that what will happen, instead of using only cement, if you add a textile fiber to it, it will impart more strength, it will impart more reinforcement, so it will have a good flexural strength like a cement composite. Then if you want to make other materials like a sheet molding compound or a doff molding compound, where if you want to make sheets, parallel sheets, if you want to make like a molding material, molten material sheets, if you want to make, or if you want to make something like a powder, there the molding compound can be used, this glass fiber can be used as a reinforcing material, so that you can use any kind of a molding material like a die molding or injection molding. There are different molding techniques are there, where these glass fibers, after mixing it with the polymer, you can make a composite. Okay, and e-glass, I have already told you, it is a electrical resistant glass, but it does not have that high strength when compared with the S glass, but it has also some good application in composite, wherever the composite requires good insulation, like an electrical insulation. If you want, there you can use this e-glass, but the problems are there. Its acid resistance is poor. If you see, it dissolves in dilute mineral acids. Okay, so that is the reason, wherever applications you require a very high strength and environmental protection or an acid protection. So for that application, for example, for a rocket motor cases, to cover the, keep the enclose the rocket motors, this S glass can be used. And there are other applications also. This you need to understand, like acoustics. Acoustics means sound insulation. Okay, wherever if you want to construct a particular room where you do not want the unnecessary noise disturbance to be there, there this glass fibers in the form of a wool can be used. It can be broken, it can be glass wool is there, that is a different form of glass, it can be used. So this is another thing where there is a application called the acoustics can be used for this. This AR or the alkali resistant glass can be used. And E-glass, it has a good electrical resistance. Apart from that, you can use it for the fire resistance also, because you see the melting temperature is very high. Normally, if you observe any kind of a electrical resistant, this fire resistant fiber normally should have a high melting point. If you just to recall our discussion on aramid fibers have a high melting temperature and glass transition temperature. So there, this glass fiber also has a good flame resistance, and it can be colored by using a dyeable sizing, means it can be colored. If you want to just color them for any application, that is also possible. And it has a good thermal resistance also. I have told you it's a fire protecting fiber. Glass is a inherently flame retardant fiber, like an aramid and carbon. Like aramid, not carbon. If you see, aramid is comparatively, this glass is also a inherently flame retardant fiber. Okay. Apart from the these applications which I have told you, there is a thermal, acoustics, and electrical or windows or glazings, wherever. Apart from other applications are there, like optical fiber communication, some optical fiber cables. This can be, it's usually made up of a glass fiber. Okay. Glass fibers can be used in that application also. So there are diverse application from the glass fibers. Okay, so with this, the discussion on glass fiber is completed. It's one of the commonly used high performance fiber and the inexpensive fiber, and it has a very good advantages, and it is more used in the technical textile sector. So I am stopping here for today. If you have any doubts, you can ask, or we can end our discussion here.